Hey everybody, welcome back to the Metal Mill 52 workshop. My name is Bill, this is my shop. I'm working on an LBSC TICH, which is the little tiny locomotive sitting on a piece of wood right behind my big locomotive over there. And in this week's episode, I made the first several segments you'll see are me making these rocking levers that are silver soldered onto a shaft that will activate the valves. And in the last few segments, you'll see me using a couple of jigs that I made for making the stop collars and the eccentrics and then cutting the drive pins. So I hope you enjoy this week's episode. Please give me a thumbs up if you do. If you have a question, let me know. I'll do my best to answer for you. If you have any comments, please let me know. I'm wide open to any suggestions. And again, I appreciate all the new subscribers. Thanks everybody. Have a great week. All right, starting out on the lever arms and so forth for the titch. First thing I did was cut a couple of pieces of 3/16 inch drill rod, cut them off exactly 1.5 inches, got them all cleaned up. I dressed up the ends in the lathe, so it'll be nice for the silver soldering. And then while I'm at the lathe, took a piece of 1/4 inch hex steel stock that I have. As you can see, there's some chucked up in the lathe right now. And I turned it down. I did a 5/16 inch length down to 1/8 of an inch, and then I took a little bit more off just to get it about 15 thou more off to get it the right size for the major diameter for a 440 screw. And I used my tailstock die holder to do the threading, the 440 threading on there, and then I cut it off. The head of it is, excuse me, about 1/8 of an inch tall. So made the first of these. I don't know if I'm going to heat treat these or not. I have case hardening materials that I could use for the screws, but the book doesn't call for that. I may do it anyway, but I'm about to make the second one. I'll cover the steps very briefly if you'd like to see that. Okay. I can't remember if I had the camera on for the last section there. What I'm doing now is going in 1/8 of an inch, or 3/16 rather, taking off that final 13 or 14 thou on the edge there. Let's see if we've got it down small enough. The major diameter should be 0.112. That's 0.114, so 2 thou. What I'm going to do is just file that last couple thou off. I've got the 440 die in my tailstock die holder, and as you can see, you probably can't see the thread at all, but I'm just threading it by hand. Obviously with these small, like miniature tap sizes, tap and die sizes, I don't do a lot of power tapping or threading or anything. You can see there's a set of beautiful threads. I'll do a close-up after I do the cutoff operation. But the other trick, I mean, it's a well-known thing among machinists, is when you're using a tailstock die holder like this, it says start from this side. So I take it out and I reverse it. So it gets me the chance to cut the threads all the way up to the shoulder instead of that little lead in there. I'll show you that in a second. Here we go. I've reversed it. It kind of looks counterintuitive because this side is dished, but these have the threads all the way cut up. So now, since it's reversed, I can slip it back on my die holder, and then ever so carefully, because you don't want to goof anything up at this stage. Let me crank the wheel out a little bit. I've got a board and a weight as my low-tech camera support. Just gently thread this on, not go crazy with it. I'm basically just chasing these threads that have already been made, and I'll get my flashlight out so I can see what I'm doing. I'll just twist until I get to the shoulder there. You can feel it when you get the major resistance. You know you've gotten all the way to the end, but it just makes the threads more precise, in as much as when I go to put this together, I shouldn't have a lot of slop in the part, which that's what you're shooting for, a nice accurate part. So now the only thing that remains is to cut it off so I can switch over and put my cutoff tool in here and cut it off. I slowed the lathe speed down. I use 70 TPI for cutoff functions. And all I've done is to mark the edge, the front edge of the cutoff tool right at the bottom of the screw head. I moved it over 1/8 of an inch. And just remember as I go through here, just run the file on it a little bit to take off any burrs that might get raised on the hex head. Make a little more professional looking machine screw when I'm all done. It's a little bit of a painstaking process, which I will cut the camera off so you don't have to endure the whole thing. So there's what the screw looks like when it's done. It come out really nice, but it has this little burr on the end from the cutoff. So what I do is reverse them in the 5C collet chuck, and I use a screwdriver to pry it open a little bit, just so I can slip it in there, leave a little bit sticking out. I may need to crank it out a little bit. There we go. Here we are. Leave about 1/16 of an inch or so sticking out for the head. Tighten it up good, because what I'm going to do is, well, I'll show you. I'm going to cut it off with the tangential tool holder here, and then I file the head, and I'll show you how pretty they come out. There we go. Okay, the stem is removed here. Just make sure we get the head nice and flat. Move that out of the way. Tidy things up here. A couple passes with the coarse file to knock off any big burrs. And I've got my smaller, finer file here. Just try to put a little dome shape on it. Make it nice and pretty. That ought to do it. Now we can loosen it up. I'll show you a neat little trick here too. Get it nice and loose. I like to use the magnet end of my scriber to help with fiddly little steel parts like that. And you can see how, hopefully you can see how pretty that head came out. Looks like a professionally made screw. Only took me an hour of lathe time for the two of them. Okay, now that we've made these small parts and they came out nice, the next thing to do is to lay out the excuse me, the actual rocking levers themselves. And this is, to me, this is one of the fun parts about a project like this, taking little pieces of basically would be scrap. So there's an 1/8 inch steel here and 1/4 inch steel here, and I've simply laid out the lines for a 3/8 inch wide strip on each of them and gone ahead and marked where the holes will be and use my little center punch to punch them. Here we go. So you can see, I just wanted to point out, all I use for the bluing is a Sharpie. Get these big fat Sharpie markers, and then the angles and the radiuses, I use these radius gauges. I bought a set off of eBay. I just watched and found a set. I think it was missing 1 or 2 pieces maybe, and it was kind of rusted and neglected, but I got it for a song. So if you watch, you can get good bargains on these. These are handy for laying out the little circles that you need. So what I'm going to do is, you can see I've got 2 pieces laid out on both pieces of metal. So my game plan is, now that the layout's done, I can put them in the mill and drill and ream or drill and tap the holes that are needed, and then the last thing I'll do is cut them out. You know, they're easy to machine while they're rectangles like that. So this one, I'll have to mill out an 1/8 inch slot in the center, in the lower portion of these. So I'll just, cut them out as rectangles and work them that way. Okay, so here I am making I'm almost finished actually with the initial machining operations for the outer or upper of the arms. And basically I took the piece as I laid it out, and as you can see, I'm holding it in the little soft jaws. Those are super handy for things like this, and using the DRO to make sure my spacing is spot on. And I drilled and reamed a 3/16 inch hole here, and then a drilled and tapped a 440 hole there. Nothing to it. So this one's pretty simple. The machining is now complete on this piece. The other one, the thicker one's got to get a slot milled into it, and then a tap, drill and tap the top of it for a lock washer or lock bolt. Okay, so here we have the 2/4 inch thick pieces. They're drilled here in the bottom part, what will become the bottom part, and drilled and reamed in the top there. So the next thing is to drill and tap a number 440 hole in the top of each of these. And then, while it's still a rectangle solid type material, then to mill an 1/8 inch slot 5/16 of an inch deep in each one of these, and then cut it out to its nice rounded shape. Just a quick note here, I did finish the inside rocker levers and they came out fine. I'll do a little more detail work on them, but they're drilled and tapped 440 on there, 3/16 inch hole reamed here, the bottom hole, and the slot is milled. I wanted to point out something for the outside rockers. It's just 1/8 inch steel, and there's not much for the rods to grab onto. I had drilled and reamed those 3/16 inch holes, and putting the 3/16 inch silver steel or drill rod in there, it was very loose, very wobbly. So I knurled the edge just to give it some area to make some contact with, and I think that'll be fine for silver soldering. I do need to put these back in the lathe and then file smooth the whole area that's not the 1/8 inch, because I don't want that knurling to interfere with the bearings. Interesting, in the book, LBSC talks about drilling the whole undersize and just basically making a force fit, which I didn't think that was a very good idea either, but that's how he addressed it. Probably the best thing of all would be to make these arms out of 1/4 inch steel as well, and then just mill away the area that doesn't need to be that thick. In other words, the top parts. But we'll see. I just wanted to point that out. Hopefully the alignment will be good with silver solder. When I first put them in there, they were very wobbly. I'm going to try out my new fire bricks so you can see the setup. Got my little knurled ends. Go. And I put the flux on the ends, and got a piece of silver solder inside there. My plan is to heat from the outside, draw the solder into the joint on both of these. We'll see how it goes. Okay, that seems to have worked out pretty good. It just took a second to run the torch, get them super hot. This one came out really nice. Got a little fillet on the outside there even. Anyway, I've smacked on these a little bit to make sure they're secure, and they are. I dipped them in water. That's what the bucket is there. Cooled off, smacked on them a little bit. Now I'll pickle them and clean them up, and we'll see how they look. Here we go. Here's the rocker levers all cleaned up, and the little screws that I made to go with it. And I have not heat treated them yet. I'm still not sure about that. I'm just going to leave it like it is for now. So I've checked the fit. They all fit good inside the locomotive. And here is the inside levers that are made out of the 1/4 inch that have the slot in them. What I did for cleaning up, I used the Dremel, as you can see here, with a little relatively fine sanding drum, and then I used a succession of the polishing, these Scotch-Brite kind of emery polishing bonnets, whatever you want to call them, and also ran the 440 tap through just to clean it up, clean up any of the tap surfaces again. So let's try a test fit in the chassis. Alright, here we go. This is what we made. This is what it looks like. Pretty happy about it. progress so far. There's the two of them inside the chassis. Naturally, I'll cut these screws much shorter when we get to actually setting timing and so forth like that. They're just little 440 screws I got in there just to keep the pieces together more than anything else. So, flip it around. That's what this side looks like. Making progress, bit by bit. That's all you can ask. Kind of that's the point with a project like this. It takes so long. The idea is to get a little bit done every day, and sooner or later you'll be done. All right, now is the momentous occasion. It's time to go ahead and press off the wheel on the little LBSC TICH, and I think these were just pressed on. I hope they didn't use any Loctite. I don't think they did, but my game plan, I've got it here in my Binford 6100 6-ton press, and there's a story behind that I'll tell you sometime if you like. But I've got a little piece of 1/4-inch rod here is my ram, and I've got the wheel set up, supported here in this device, and then I've got some rags and a piece of wood down here below. So right now I'm just pushing the axle out of the right side wheel on the rear. Hopefully we're getting this on the video. Wow, that was pressed. Okay, got it reset here, and looks like we're moving smoothly out. Yeah, there we go. That's a lot better. Must have caught a piece of the wheel with the first one, but it's coming out really smoothly there. Alright, that's a relief. There's my little pusher rod, and there's the axle, and yeah, it doesn't look like there's any Loctite on there. It's just nicely pressed on, that's for sure. So now I'm good to go, so I can remove everything except this, and I'll start to build the eccentrics to go on the rear axle. And here's the little rear wheel. And the reason I went ahead and pressed that wheel off the rear axle is that I did finally receive the second eccentric strap from the good folks at Reeves 2000 that came in the mail this week, just yesterday as a matter of fact. And this is kind of interesting. I dug out a couple of jigs. This is the jig I used for my Allen Mogul eccentric strap. There's not much to it, but I saved that just in case I ever built another one. And it'll serve as a good model for these. As you can see, I need a bit. If I'm going to make a jig, it'll be a heck of a lot smaller. But I also have the jig for the eccentrics, so that's kind of cool. What the whole point here with these screws and the washers is that the washers were hold downs, so that gives you a little idea. You can see the eccentric is that's where the hole for the eccentric was drilled. While I'm showing my jigs, this is kind of cool. Here is a brake jig. It's at a 3-degree angle, and that's what I used for machining my brake pads on the Allen Mogul. And also, I saved this. This is the jig that I used back in 2013 when I was drilling the tops of the brake cylinders. So match the cylinders to their covers. I didn't videotape it last night, but I started out with some stub axles like I got from my buddy Russ that I've used for a lot of different projects lately. These things are great. It's some kind of really nice stress-proof steel, I think. But I've got it chucked up in the 5C chuck, and I turned it down to the 15/16 dimension there. Got it carefully. It's right on the dimension. So I thought before I do anything else, I'll drill a hole inside and bore the appropriate size for the axle, which mine is larger than the book calls for. So I'll do that and then see if I can slice off 2 really nice 1/4-inch sections for the stop pipe. Okay, after the first pass I mic'd it, and it was 2 thou too tight, so I'm taking a spring pass now. Go down again 3/4 of an inch. Keep trying to sneak up on it. Once again, I'm certainly not the world's expert at boring tools, but I finally got, after numerous passes, I got this to a nice, perfect fit. This thing, it slides in there. It's certainly no shake to it, and it fits just perfectly. So I'm really happy with that. Now I can mark off, these are the stop collars. I can blue the face and mark off the center portion, and then part it off at 1/4 of an inch. Okay, I blued the face of the part with a Sharpie marker, and I put my diamond tool holder in here. I carefully set it at center height using this, and I've marked off, scratched off a nice half mark. You can see that right at the center line. So the next step, I'm just going to part this off, and then when I get to machining this piece, I'll be able to mark the line that goes below there, and then mill off that section, and then drill and tap the portion on the top. And I'm parting off the first one. It's going pretty well. I'm not going to video the whole thing because I'm afraid I'll mess it up. Spoken by a true parting off coward. Here I am on Thursday night. I made one of the eccentrics. I'm parting it off right now. I had to use another one of my supply of Russ's stub axles. Didn't have enough left on that first one. Okay, now that I've made both the stop collar blanks, if you will, excuse me, and the eccentrics here, got them all finished up last night. The next thing to do is to make jigs for the machining operations of them. The one for the stop collars is going to look a lot like this. This is the one from my Allen Mogul that I used for the machining of the actual eccentrics. So I'm going to use this block here. Picture's kind of worth 1,000 words. I've listed all the steps that I'm going to go through. I figured the stop collar is a little bit easier, so I'll start with that one and with this little hunk of steel, and we'll move forward. I'll show you the steps as I go along. Okay, I've cleaned up both of the blocks that I plan to use as my jigs. This is the first one I showed you already. Here's the second one. Just using the same cutter that I use a lot for the Gingrey Shaper project. This is a large shell mill type thing. It cleans up aluminum beautifully. So I'll leave this square away. Checked all the corners are, I'm not making square blocks, but perfectly rectangular with square angles. That's kind of my point. And then the edges, both sides are flat. Let me show you the other side of this. See, there we go. So cleaning it up good, getting all the saw marks out of it, so it'll be nice when I set it in the vise and actually make the jig. So far so good with the first one. This is the first stop collar. As you can see, I took the block and I made a hole about 1/8 of an inch deep, just big enough to fit the stop collar. Then I used crazy glue to hold the stop collar in, and I've got my 832 screws here to kind of clamp it in and hold it steady. And the combination of those things worked out well. I touched off the DRO and right at the top of the stock, and I just milled off 1/8 of an inch there, so half the distance to the goal. Just need to file that and remove it and replace it, do the second one. Okay, that's the second one. You can see it pretty good here. I don't know if this will come out or not, but here's the scribe line that I put on it while it was in the lathe, and I put some little pip marks and made a scribe line across this as well for the alignment. The first one I didn't align it really good. The crazy glue kind of grabbed it on me. But just like the first one, now that I've gone ahead and milled off 1/8 of an inch depth of cut there, I'll just file it a little bit and remove the screws, which remarkably, this thing held really well. Now I only took cuts of like 10 thou deep at a time, so I had to go make several passes obviously, but considering I was relying on 2 little screws and crazy glue, I thought that, you know, it worked out just fine. I'm really pleased with it. So I'll take the screws out now. I'll use a heat gun on the part and just pry the part out very gently, and it won't hurt anything. And before taking the second stop collar out, I'll show you what I did was I tipped it up, and I had it, since I knew what the center line was, it was easy. I was able to mill a little slot down there and a flat spot on top of the thing, and then I drilled it and tapped it for the 440 screw. So that's the second one. Now I can use the heat gun, remove that, put the first one back in there, and do the same thing. Well, making the jigs and then machining was easy after getting the jigs made, but I'm really happy. You can see how that came out. You can see the drilled and tapped 440 hole in there. So very stoked about this. This jig. I would highly recommend something like this if you have to make parts like these. So here we go. I got the first eccentric set up last night, and I drilled and reamed an 1/8 inch hole here for the pin, and I did on the other side. My axle, it should be simple. You could drill and ream a 3/16 inch or 3/8 inch hole. My axle is a little bit bigger than 3/8 inch, so what I had to do, I drilled it out with a W-size drill bit, which is about 2 thou shy of the needed diameter. And then what I did, I used this boring head, I just creeped it out. I just did a couple of passes, just to essentially like spring passes. And now I'm testing it. I just tested it, and that is a perfect fit. I'm very excited about that. So I'm going to leave the boring head set up just like it is. I'll have to take it out, put the other eccentric in, do the same kind of thing. But now I've got my head set. I won't have to adjust it at all. I'll double check everything, but I shouldn't have to adjust it to do the same thing on the other eccentric. I was kind of sweating that detail. Here's my setup for the little 1/8 inch drill rod pieces that will be the drive pins. I've got my trusty Dremel tool and my little fabricated aluminum holder, and I set the DRO for 3/8 of an inch, so that's 1/4 inch thick eccentric and 1/8 inch sticking out. I won't run it and blow your eardrums out. Alright, this will be the last segment of this week's update. I did cut off the little 1/8 inch drill rod pieces, 3/8 of an inch, and I made sure they were the exact right length. I put them back in and filed them down. I need to clean these things up a little bit before I can Loctite the locking pins in there, or the driving pins, the 1/8 inch driving pins inside. But these are the pieces that I made this week. It doesn't look like a lot. Well, that and these. So I guess it was a pretty productive week. Next week come the eccentric straps.